All right, so today in this workshop anyway, we're going to be exploring building your own autograders in NetsBlox. I'm going to start with a few slides just with some of the background kind of information, not spending a lot of time on them because NetsBlox has already come up in a few different lightning talks and things like that. But just kind of the bare necessities before we can jump into the exciting parts for working with these things in a hands-on sort of fashion. So I'm Brian Broll. I'm a research scientist at Vanderbilt, and NetsBlox was one of the products of my dissertation. And my supervisor, or my PhD supervisor, was Autograder. I'll be presenting today with Cliff Anderson, who's also here, so feel free to give a wave, Cliff. And he's also at Vanderbilt, and we collaborated on a number of different projects. Okay, so before we start with the exciting hands-on portion, as a very brief intro to NetsBlox, in case you haven't heard of it yet. NetsBlox is an extension of Snap. It provides a bunch of new features like networking capabilities, which is one of them that which was one of the main motivations for creating it, so we could teach like distributed computing. But we also have added a number of other features too, like undo capabilities, collaborative editing, sharing shared projects where both people can edit the same version of the project, much like a Google Doc where you can log in and work on the project, someone else can log in and work on the project, both collaboratively or of course offline, and then sharing libraries and things like that, and a bunch of other features too. So one of the new networking concepts that's relevant for this workshop is this concept of a remote procedure call, which enables users to write code that's basically implemented remotely. So it's like a custom block, but the execution and the implementation all run somewhere else. So some of our examples include some RPCs using Google Maps, like getting maps and converting latitude and longitude to X and Y values. There are a number of RPCs pertaining to cloud variables, like setting variables, reading variables, things like that. And then the one that we'll be focusing on is this autograders service. So this is basically a set of RPCs that let you create your own autograder. So then create your own autograder from within NetsBlox. Now, before we jump into the code too, I wanted to take a moment to talk a little bit about our motivation, so it's clear when we start working on it why we emphasize the parts that we did. So we really wanted to get some exercises or tasks or things like that were easier to adopt into the curriculum. So it's nice, especially if you're looking for something small like a bell ringer or something like that. It'd be nice if we were able to have something that's auto-graded, a small scoped activity, and things like that. Now the fact that it's auto-graded and automatically loaded and provides a little more structure can also make it more conducive to some other contexts like independent studies, if they want some more, again, structure or kind of guidance, like a path to go down or a track, or MOOCs as another example. And another goal or idea was that if we're able to use NetsBlox to build these autograders, it not only lowers the threshold for being able to create these, but it also will facilitate like reusing and remixing, because now you can use all of the features that you can in NetsBlox to help build and remix projects, and you can basically apply those to the creation of autograders. All right, now this is the last slide. Okay, this is the last slide before we start jumping into the hands-on portion. I wanted to keep, again, the slides at the beginning a little bit more concise. But I know I also have a tendency to go a little fast, so feel free to speak up, raise a hand, turn off your mic, and just say something, whatever you would like, if you have any questions. So an overview of kind of this process of creating autograders before we jump into it is we create an autograder in NetsBlox, shown kind of with these scripts here. Now these are using a few custom blocks to make it a little bit easier, and we'll get into both using it with custom blocks and making one from scratch during this workshop. And then we use this, we call this RPC, this create autograder RPC from the autograder service. And we pass it essentially like a configuration or list of lists that contains information about the autograder, like what its name should be, what assignments are required. For each assignment, every assignment will have like a name and a starter template, and tests, things like that. Again, we have this library that we'll start with that hides a lot of those complexities, and it just kind of lets you compose your own autograder, complete with a bunch of different assignments that are all autograded from some existing blocks. Now, as soon as we create this autograder, now this autograder will be available at this URL. And we have a custom block to help with that too. So this will open a tab with the autograder with this given name. So in this case, like NetsBlox exercises. And then it'll open it in a new tab so you can test it out and copy and paste the URL and share it with students or whoever you want to be able to access these autograded activities. All right. Now, with that, I think the best place to start is maybe to jump in and start seeing what this looks like from a student's perspective. So, one second, let's get this chat open so I can share this link. All right, so I'm posting a link in the chat, and this is the link that I'll be going to now. So this is the URL that was provided basically when creating this, when I created this NetsBlox exercises like set of activities. So when I load this, when I navigate to this URL, you'll notice that this looks like your standard NetsBlox, or if you're more familiar with Snap, because again, NetsBlox only is an extension of Snap, a familiar environment nonetheless. But now in the top right, we have this little extensions button, this little kind of puzzle piece. And if we click on it, we'll see that now NetsBlox exercises, or this extension has been loaded, or this set of activities is available now. Make sure you copy the whole thing. Sorry, someone just said that the link doesn't work. So make sure you copy the whole thing. Sometimes if it's highlighting it, it doesn't, the syntax, or the URL detection can sometimes miss the trailing square bracket. Yeah. Anyway, so now we have this puzzle piece available. We'll see that when we click on it, we have this NetsBlox exercises menu item with a bunch of different activities that we could start. So to start, between, moving average, at bash, cipher, etc. So I think we might start. Let's start with maybe Caesar shift. Thank you, Akush. I think Chrome turns it back and forth automatically, so it might not have been. The spaces and quotes might not have been escaped correctly.
Yeah.
All right, so if I select an activity,
even my link misses the last bracket, so just make sure that that last bracket is still included.
Yeah, maybe I'll just make a tiny URL for it quick. Actually, if someone doesn't mind making a quick tiny URL and posting that, so we don't have to worry about the hyperlink detection being goofy and URL encoding things.
I'll do it.
Okay, so now if I open one of the exercises, this is kind of the view that the students would see, or the users, whoever wants to use this, do this auto-graded activity. So first, I've got these comments that are kind of describing, the Caesar cipher is a type of substitution cipher in which each letter is shifted by a fixed number of positions. So we have a sort of description here. And the main activity is editing this custom block on the left. And this one is available as a Parsons problem. And before I work on it more, if I perhaps don't understand quite from this description, we have a couple examples that are showing how the block is used here on the left. So we're shifting ABC by 1, and that should give us BCD. We're shifting ABC by 5, and then by -5, and we'd actually expect this to give us ABC again. But before I continue further, actually, maybe I'll throw some of these together. So maybe I say that we, let's say I just start by just reporting, I don't know, the text. So this certainly won't work, but this one will look right. ABC gives me ABC. So if I go back to the menu, we'll see that now it's changed. So it has an option to grade the assignment. And now if I view when I select grade the assignment, we'll see a bunch of test cases that have been created for this one. So it expects us to, if we shift with no shift value, it should not change the input. So shifting no shift by 0 should still report no shift. There's so Simon just commented in the chat. So if you're seeing an empty project, that actually is expected. So when we first loaded it, remember we had this extension button now that lets you just jump between or do whatever it is that you like. So this is where you can select. So I went through that maybe a little bit quick. I just jumped right into Caesar shift from here. So anyway, so I made a very, so basically I came up with an incorrect solution. We can see that this one is test case is passing, but the rest are not. So if I quick throw together the solution for this, start by defining these script variables. Then I'm going to go through each letter and keep adding, and sorry, of course, initialize shifted letters to an empty list. And then I'm going to take the Unicode of the letter plus the shift amount and mod 128, and do some fun things like that, and report this at the end. So don't worry too much about the content of this implementation. But anyway, now if I put this together and then try to rerun to see how I did this time, we can see that now all the tests are passing. And then of course we have some other scripts over here on the right if people want to kind of extend this further. So for example, these scripts are the beginning of an encrypted chat client. If you wanted to copy your roles and then start actually using this in a more like open-ended and building your own project sort of way. Now those portions aren't auto-graded, but my hope with a lot of these exercises was to give a scoped activity that's easy to auto-grade. In this case, this custom block, as well as along with some examples that make it really clear what the block should do, and then some ideas for extension. Like we can see here, could you add encryption to another communication app, such like a chat server? If you don't know the key, how might you try to break it? So these kind of probing questions. All right, so is the order of the sequence also evaluated? So right now, these tests are just testing the input and output. And we'll see what types of tests we support at the moment as we go forward. But these tests for this one, we're just looking that if we call this shift block with these test cases, in other words, this text and this shift amount, that we get the expected values. So in other words, we're not actually like evaluating the structure of the blocks that are put together, but just just using input and output test cases right now, or input and output examples or something like that. All right. So are there any questions about how to use these autograders, or how to interact with it from kind of like the user student perspective at the moment? All right, so now the question is, we can see how students would interact with these autograders, and it is worth mentioning that like there is currently some support for like submission. Like you can, right now only Coursera, but we've been thinking a little bit about how to again fit these into a context of like a MOOC or something where we have a little bit more structure. So there are some other features, but I'm not going to dive too much into those just yet. So now we've seen how a user would interact with this autograder. We can see how they load the assignments, work on the problems, get the feedback, and since this is still just that's your standard NetsBlox environment, you could save them and do any of the other sorts of things that you would want to do with a project in NetsBlox or Snap. All right, so now the next question is, now that we can know how to use them, how can we actually create an autograder? So if I just go to your standard NetsBlox environment, I'm not worrying about any like fancy URLs or things like that. We have this network tab that you may not have seen before, and this is where we have features like sending messages over the internet, which we're not going to focus on in this workshop, but also these blocks down here, this call, run, and error blocks, which are used to call RPCs, or functionality that, again, executes remotely. And you can run it just like it's any custom block or something in your project. So if we select this call block, this first dropdown is a service, and a service is a collection of RPCs that are grouped together to solve like a similar, or to work on like or it was grouped together by functionality essentially. So if I select the Autograder service, we can see that there are a few different options here, like create autograder, get autograder config, or get autograders. So I'm going to use create autograder. It looks like I'm actually not logged in. Okay. So, what we're going to use this create autograder RPC, and it provides it requires this configuration to be passed. So before we jump into building on completely from scratch, I'm going to look at building one like we saw here, where we're using a library of existing problems like @bash, cipher, Caesar shift, and we can select if it's a Parson's problem or not. So this library is actually available. I'd like to make this a more polished website, but at the moment anyway, these are available on this GitHub repository. So this contains a list of all the different exercises. You can try the different templates here. So if I wanted to try out like, I don't know, FizzBuzz example, I could click on that and it would open up the FizzBuzz starter template. I could decide if I like it or not. But I'm going to focus on this library right here, these autograder tools. So if we download this file, so if you download so I'll actually try to show by example what we can okay, so a single set of blocks, so there's a question right now about if only one block set at a time can be evaluated. Right now, the tests can grade, they specify what custom block they want to test and what either the inputs and outputs should be, or or they can test it in a little bit more advanced way, where they provide their own function to test the block. So you can test a set of custom blocks in a project. So multiple custom blocks can be tested, but of course you can only test what's been loaded, if that makes sense. In other words, more than a single custom block, you can pick a bunch of different custom blocks. Right now I've been focusing on just one to keep in these exercises, just to keep it kind of scoped nicely. But anyway, that link that I just posted is a link to the library that we'll be using. Now I already have it downloaded on my computer. So if I just open this library, I'll see that I have a few custom blocks that'll help me build this autograder. So we see this gives us 4 of these blocks. The first one that I'm going to start with is the one that actually creates the autograder. So I'm going to call this one like my autograder. And then it expects a list of assignments. Now I'm going to start with maybe so you can select some of these exercises that are just blank, or you can select the Parson's problem variant of them. So I might stick with the Parson's problems for now, and maybe I want to focus on just encryption. So I'll just grab some of them around encryption and code breaking. So just create a few different exercise, or select a few different assignments and add them to this assignments list. If I click on this, it'll actually return the configuration really for this. And there's more details on the on really the schema that's used here, but we don't really need to get into that just yet. Now, if I run this block, we can see that it returned OK. So it seems like it was created without error. Now I can copy the name and paste the name of the autograder I'd like to open in a new tab. And now when I click on that, and when I run that block, we'll see that I have that extensions button again in the corner. And now I see my first autograder. And we can see that it has 3 activities available: Caesar shift, cracking the Caesar shift with brute force, and cracking the Caesar shift with a partial solution. I can open it as you'd expect. And now we can see the assignment. And of course, complete with all my tests. So, all right, so now we can see how, given this collection of exercises that we've been curating in this repository on GitHub, we can compose our own autograder from these existing assignments, which is a good start, and I think it's really cool and exciting. You can come up with various tracks and a lot of reusable things, so people can take them and remix them and hopefully make it a lot easier for people to quickly learn some of these concepts, and especially in these unstructured environments like MOOCs or independent studies. But it would be great if we could actually create our own. So now we'll try to make another autograder where, instead of just relying on these existing set of problems or exercises that have been made available, we're going to actually create our own autograded activity from scratch.
Ryan, can I ask a couple of questions before you switch over there?
Yes.
So we had to load this JavaScript library, but basically the reason is because we haven't really released this. So eventually it will be part of the regular NetsBlox release, so you can just load it from the menu, right?
So we could do it. So are you talking about this library here being included in this set of libraries?
Yeah.
Yeah. Oh, yeah. I mean, that definitely is I think that would make it a lot easier, and I think that's the plan, especially when we go into creating our own. Like, these things would be nice to be made available, because I'd like to make it so it's easier, so you don't have to go to that URL. So I was planning on either making it a link from a website with the NetsBlox exercises, or available here, or most likely just both. So if you're looking at the website of NetsBlox exercises.
And then the second question, as we keep curating more and more exercises, this library will basically just pull it from GitHub automatically, right? So we don't need to do anything.
Yep, that's exactly what it does right now. So right now, actually, if you that GitHub repository basically has some built-in scripts. So if you add a new project to it and it has tests, it'll update the library automatically. And then this library actually pulls it from GitHub right now. So right now it just goes and fetches it from, it basically constructs the URL, then fetches the tests and keeps track of what the starter template should be.
Cool, thank you.
Yep, no problem. All right, so now that we've seen how students can interact with these autograders, and how we can build our own autograders from a curated set of exercises that we've been curating here at Vanderbilt, we now will jump into how can we create our own from scratch. So the first thing that we're going to be using here is so of course we're going to be using the same RPC that we just saw before. So we're going to be selecting the Autograder service, and we're going to be using this create autograder RPC. Now, to make our life a little bit easier, there's a library that we're going to be using that's under community. And this is another one that will eventually be moved over to official. just want to make sure that we've really smoothed out and made it as easy to understand as possible. So once it's completely out of, once we've completely like settled upon the API and such. But this gives us a bunch of blocks that will help us create our own assignments, and a couple blocks that'll look familiar. So this Autograder block should look familiar. Opening the tab with the Autograder looks familiar. But then we have a bunch of different ones here. So specifically, like we have an assignment block here that expects a name of the assignment, a URL for where the starter template is, and a set of tests. And we'll be using this instead of those drop downs, these ones like the assignment as a Parsons problem. Now we're going to actually be composing our assignment, I guess. Okay, so suppose we want to create an assignment that's just called greet. Like it's just going to be an assignment where students are implementing some block that will greet some person. So given a name, it'll say like hello so-and-so, or like hello Brian, or hello Jens, or something like that. So we need a starter template and we need a set of tests. So in order to get a starter template, let's actually create one. So I'm going to open NetsBlox in another tab, and I'm going to create my starter project for this greet assignment. So I'm first going to make a new custom block that the students are going to be implementing. I'm going to call it, it's going to be a reporter. I don't know what, make it, call it an operator. Greet is a name, is one of the input arguments. And for now, actually I can make it a whole Parsons. I'll leave it just blank for now. So I'm going to add this greet block to the center. I'm going to put a comment here and say, can you implement greet given a name, turn hello name. Anyway, this is not a great description, but but I think it'll work for the for our example. And now I can just save this project as greet exercise. I'll save it. And now the last thing I'm going to do is I want to make sure that this thing is public, so I'm going to share it. So now that I've shared this project, I know that anyone would be able to load it in. I don't have to worry about them, of course. Like I know it's publicly available to be loaded in by anybody who's trying this activity. And now the template URL is going to be actually, so it's not immediately obvious what that should be. So we have this helper block that will be useful here. So it's the public, it'll give us the public project URL for a project, in our case, greet exercise, by some user. So in my case, I'll just drop in my username block. There we go. And I can just drag this public project URL block into this template URL slot. So I know this is the starter template. And now we just need to come up with some tests. So we have these two blocks in the middle here that start with a ring, these two here, that are two different ways that you can define tests at the moment. So this is the block that's being tested, should report some value given some inputs. That means that I actually need to have the block that I'm going to test. It doesn't really need to be implemented, but I just need to know which one it is. So I can export some blocks here. And I'll just drag my new blocks into the into our original window where we're actually building up the autograder. And now I can say that the greet block should report hello Brian, given the input Brian. And this is one of our tests. And then maybe I'll make another test. I'll just duplicate this and change the name. Hello, Cliff, given the input Cliff. Now this bottom test I'm not going to use just yet. It's a but I'll just start with this simpler one to begin. So now this is now defining an assignment called greet. I guess with some enthusiasm because we added an exclamation point. And the template URL is our public project URL for the greet exercise. It's by myself, the one that I made. And the tests are defined here. So we have two of them. So both of them are testing the greet block in our template. So this block right here. And this greet block should report hello Brian, given input Brian. And it should report hello Cliff if given the input Cliff. So now we can add this assignment as one of our assignments. And our autograder can be called my greeting. Now when I create this autograder, we can see that everything seems to be okay. It was created without error. Now I can open a tab with this autograder loaded called this autograder that we just created. Now we can see that my greeting exercise is available and I can start the greet project. And now it loads the starter project that we had just created. If I look at the tests, when I go to grade assignment, I can see that the two tests are greet Brian should report hello Brian, and that failed because it didn't report. Greet Cliff should report hello Cliff, and that failed because it didn't report. So now just to show that it works, we can say hello Brian. Now when we rerun it, we have one passing test. And now we can see that greet Cliff should report hello Cliff, but instead it reported hello Brian. That's a bummer. So let's fix that. So now it's actually right it the correct way. So hello space Brian and exclamation point. Now when we rerun our tests, there we go. We've got all of our tests passing. Yeah, it's very similar to unit testing and test-based languages, text-based languages. So I want to break for a moment to see if anyone has any questions. I feel like we went through this kind of quicker than I expected, and it's one of the challenges of doing things virtually is how it is always hard to see if anyone has any questions or if everyone's able to keep up and follow along nicely. So there's a question. All right, so there are two questions. One is asking about what the difference is between the call and run block. So the two differences here are the call block is based, all right, so, well, basically the run block is used if you're like, for example, if you're doing something like setting a variable, like in the cloud, you don't really need to look at the result for that. And you probably want to be able to connect it as a statement in some other sequence of blocks. Whereas the call block returns a value. So if you were doing something like getting a variable, you probably want to use the call block for that. Setting a variable you probably want to use the run block. And we have a question about using the other test block. And yeah, we can use that one too. So this one, all right, so this one's a little bit different. So this one basically, it's saying now, so if we start just working on it, we can say that the greet block should do something, and here's the test for it. So for example, we could say should return a string, and then our test for it expects this to be the student greet block. So this expects you to pass a function that checks whether or not it is doing the thing that it's supposed to be doing. So in this case, for example, we might want to check that what it's returning is a string. So we have this is to return some text. So we know that we want to check that whatever it is returning is text. So this student greet block is really a function. So it's really the block that the student implemented. So it's so we want to call student greet block with, I don't know, some input. And then check that when we call the student greet block with some name, it is returning us something that's text. So I can drag this in here. And now we can see that we have now 3 tests. So first greet should report hello, Brian, and hello, Cliff, but it should also just return text. So maybe I'll actually reorder these. So that's the first test. That's kind of the simplest. Now when we run this create autograder RPC again, now it updates our RPC. And if we just click on this, if we check it out, anyway, if we open up our autograded activity again, now we'll see that we have 3 tests. So greet name should return text. So now if I'm working on this activity, can rerun it. Now I can see the first one's passing because even just returning the name itself is returning text. And then of course we can get this thing or complete the activity, and then we'll see that they all pass. Here we go. We don't need the old version anymore. All right, so so that's an example of how you could write your kind of your own test. Now this one's required, especially if you're looking at some more. So for example, this one could be used to like if you're writing some test that's using like higher order functions or something like that, where it's not like you can just say the output is this function, because then you have to try to compare functions and goofy things like that. If you need to test it by like by checking how it behaves and by calling it and with different values or checking some generic property of it, because these the first blocks that we used are a lot easier. You know, it gives you this specific output given this specific input, and it just checks that these things are exactly equal. You know, when we call greet with this input, we get this exact output. But some things are harder to check that way, or you want to just check some property. Like if you have a multiply block, I don't know, maybe there's some edge case or more general property that you'd like to test. So we have this other block to help with that. Cool. All right. So technically NetsBlox is a fork of Snap. We you know, it's available at netsblox.org. And you can log in with your Snap account, or like and like link a Snap account so you can use the same credentials, but you'll have your own NetsBlox projects and things like that. So it's yeah, so now that they're introducing extensions into Snap, now we'll have to be, I guess, more careful when I say extension of Snap. Usually in the past, that was always all right. Because it's, anyway, because it was extending the capabilities, it was fine. But now that we're actually getting official extensions, I'll have to be careful with that terminology. All right. Let's see, are there any other questions? I mean, I can show other, I'd love to, if there aren't any other questions, I'm always happy to show anything else. Like if people want to see more of the exercises or anything like that, I'd love to open it up to whatever everyone's most interested in. All right, I'll show another activity that's kind of another fun one, maybe, while people are thinking. So for example, we have, actually I'm gonna wait. So a few of the exercises that we have in our curated set of exercises. Oh, sure. Links to what we built today, then I'll have to make sure I don't actually break them. Yeah, I'll save all these activities. Snapcon 1. Reader. Yeah. All right. So I'll post, here's one link, the one to the grader itself. The greeting exercise is right there. Oh, actually, then I'm going to change something quick here because this was using my username. I was doing that in case anyone is following along because I want them to type in their username instead of mine, and then you don't have to worry about typos. But of course, if you want this one to work, it's going to need to be fetching my greet exercise, because if you don't have greet exercise, that'll of course be problematic. Okay, so there's the link to the greet exercise, so the starter template. Here's a link, even though again we had problems before pasting these links into the Zoom chat. But there's a link to the exercise, the greet exercise that we just made, so like actually using it. Now it's not a big deal because if you just open the earlier one, I guess you can just click open tab with the Autograder loaded. Right. And I'll show this into StatCon 21. Maybe not the best name, but hopefully people understand. And here is, I'm kind of posting these in reverse order. So the first one that I posted is the most complex one, the one we're actually building it from scratch. So starting with a starter template that we made, creating all of our tests in here. And then of course links to the template and to the loaded Autograder URL. And then the last one is the Autograder that we made that's using the curated set of exercises. All right, so now we can switch to just to show a couple other exercises that are kind of, I guess, interesting. So we have the Caesar shift one. We have examples that are using brute force and using brute force to try to detect the key. So we're saying find a key where some text contains some like words that we're looking up. So like we might want common words like is or the or that. When we implement it, or once we have it implemented, we have some example usages here where like we have some encrypted text. And if you implement it correctly, then you should be able to actually find the key where the encrypted message contains. You should actually find the actual key for it, because this message actually has you in it. And then there's some probing questions to go kind of further about like down here, we actually have one that's a challenge message that was actually encrypted with two different keys, alternating back and forth. In other words, it was a Vigenère cipher where we had to like a really simple key, a two-length key, but then it kind of try to probe to see if students can go further and push it further. And then we have some other ones that are actually like in their extension points using some like NetsBlox specific things. Like another fun one is this counting letter frequencies. So we have this kind of progression when it comes to these encryption ones. So we have just implementing like an @bash cipher, which doesn't even have a key. It just swaps like A, Z, B, and Y, and so forth. So that just kind of reflects the alphabet. So over the center point. Then we have the Caesar shift. We actually have a key, and then you actually have to start cracking it using either brute force, or you can do it differently. If you actually have a partial solution, you can do it really efficiently then, because you just figure out how much it was shifted in your solution from your input to your output. And then we have another example here where we're counting some letter frequencies. And then you can start looking at the frequencies and trying to determine what the shift value was used for the cipher, the Caesar shift that was added here. So if we implemented this guy, just have a couple minutes, won't take very long. So why did I get that? Oh, I'm somehow, oh, I see. I'm now logged in. One moment. Really quick, because I logged in a different tab. All right, so now I start counting letter frequency. Okay, so script variables. At the end, I'm probably going to report the letter counts, initialize some alphabet through each letter. Probably going to want to warp that guy. Probably initialize our letter counts to 0 for all of our letters, 1 through 26. And now we're going to be replacing the letter. So the letter index is probably the index of the letter in the alphabet. And we're probably incrementing by 1. There we go. Now just to double check, okay, it is working. So now some of the fun things are, like this one, for example, is actually fetching a book from Project Gutenberg, and then actually doing the looking at the letter frequencies. So how often does each letter occur, and then applying a Caesar shift, and then just alternating between the letter frequencies that are encrypted and unencrypted to see if students can get an idea of why this might be useful when trying to crack it. So as you can see, it looks almost as if the whole bar chart just slides 3 places to the right. Yeah, so all the charts are rendered on the server side. So basically we have this book ID and we can actually look up which book it is. I don't remember which one it is. So let's see, get info. So, oh, it's Adventures of Sherlock Holmes. So right now we're fetching the Adventures of Sherlock Holmes, and we're trying to look at what's the distribution of the letters in the book, and then what's the distribution after it's been shifted. So this can start to lead into a lot of different, like looking into like frequency analysis and things like that, and how that can be used to be crack monoalphabetic ciphers, which I think is kind of a fun way to hopefully explore and try to, and just to try to give a little bit of guidance or a little bit of hints about where this could go, but not actually have as much structure. In other words, leave it open-ended enough to where students can actually explore a lot of different things. You know, you could switch which book is in here. You could start looking at making the problem itself harder. You could start asking questions like down here. Like right now, we actually figured that we knew the book and then we looked at the letter distribution, but you can start raising questions like, do you think that there are similarities between books or between text in certain languages? Which is true. You know, there are most common letters in a lot of different languages. So if you can even guess the language that's being used for your messages, then you can start guessing which, or start looking at like the most frequent letters and start matching those to the most frequent encrypted letters, and things like that. See, so that's why these kind of questions here at the bottom. Like, could you write code that cracks the code using the frequency distribution? How unique is the original frequency distribution to the text? Are there common trends among text from a given language, like most and least common letter? What if you don't have the original frequency but know the language of the message? You could go a completely different way and go and not look at cybersecurity, but say, given text, can I guess the language? Like, can I classify the language? Like thinking a little bit more on the machine learning road, and things like this. Yeah, so I mean, I did get through that much quicker than expected, but I am wondering if there are any other. I mean, I can keep showing off different activities of increasing complexity, but again, I want to keep this as open as possible. So if anyone wants to go a different direction with it, I would love to explore different avenues. All right. One of the things that I like about this activity in particular is that you actually, I mean, I used map here. I could have done it without. I could have put another for loop where I go through and add them all, but you didn't need too many like really advanced concepts here, I think, to be able to create such, I think, an interesting and like visualization and start getting into some of these kind of more advanced topics.
Hey, Brian.
All right, so there's a question from Ben. What kinds of data can be used in the test cases, like text, numerical values, Booleans, etc. So, all right, so basically this block, where you're checking if it should report some value given some inputs, this is essentially, you know, using a snap equals, so it's just checking equivalence. So so anything that will be equal, in snap should show up as equal here. In other words, I would probably stick to just simple primitive values, not like functions or things like that. With this other test block, this one can do a lot of pretty advanced things. And now, I guess we have time, so I'll show one of those examples too. So I'll go into an example with higher order functions. So let's see. Here's a simple one, I guess, or like the starter one. We have activities of increasing difficulty on this front as well. So we have like an introduction to basically these infinite sequences. So in other words, using a higher order function as like a generator to generate values in a sequence, as well as like mapping over these and cyclic iterators and stuff. Now, this one is an activity where you're trying to basically, this counting numbers block should report a sequence where when we get the next value in the sequence, it should just keep giving you like 1, 2, 3, 4, and all the counting numbers. So, and the test cases for this one are that the sequence should start with 1, 2 sequences should iterate independently, a sequence should remember the current position and should produce all the counting numbers, things like this. So I can actually implement this one quick. So really what we're doing is we're just, we are creating a function here where, here we go, change number by 1 and report the number. So this is a block that returns a function that starts with this, that has this number variable that keeps increasing it by 1 and just reporting it. So, and this one should already, oh, it's not, I can remember if it was or not. So now, so just to kind of show how this works first. So if we assign test sequence to this to the counting numbers, now I can just call next on the test sequence with the next counting number, and it continues to give me 1, 2, 3, 4, 5, 6, and so on. So we can see that it'll just count on forever, and we're passing all the tests. So I wanted to bring up this one because when the question I was asked was about what kind of data can be used in the test cases, and this is actually a pretty tricky thing to test, because if you look at the value of test sequence, it's actually this function. So I actually have an example. Where did I? What was it? Creator. Sequence autograders. Here we go. So this is a bit messy because I wasn't expecting to show it, but because I'm not using all of the like fancy helper blocks. But in cases like these, we have like one of the tests. Let's see, this is, here we go. So here's the test for this function. I'm just if we ignore the rest of it. I made some of those blocks to make it easier to do this, so you don't have to worry about the details of the configuration, like the structure of the configuration for assignments and such. But this is the test anyway. That's checking that that if you have 2 sequences, they operate independently. So this is the function that returns our sequence or our iterator over all the counting numbers. We call it once with one sequence, another time with another sequence. So now we have 2 different sequences, and we just check that that the next value in the first sequence is the same as the next value in the second sequence. Because if they don't iterate independently, then this first one would be 1 and the second would be 2. So this checks that the second one hasn't advanced yet, basically. In other words, so to answer Ben's question, for these simple blocks, primitive values, if you have something more sophisticated that you want to check, functions, or really the sky's the limit, that's when you start looking at blocks like these, where you do this, where you can test, write your arbitrary tests, really.
Hey, Brian, somebody started asking a question right at the same time as you started answering Ben. So let's give him a chance to to ask the question.
The context and the moment have passed, but it's a question about the call. I think somewhere you had map over a ring, and then inside the ring you had a report. And I was wondering whether that's kind of like an anonymous function in some other languages.
Oh yeah, yeah. So yeah, I'll hop over to that one again. Switch to counting letter frequency. Yeah, so it's an anonymous function. So basically what it's doing, and I don't know, maybe I should make a simpler variant for these Parsons problems. These exercises, the Parsons versions of them can have multiple formats. So they can have like a functional version and an imperative version and things like that. So that students don't have to, so that they can see more sometimes sophisticated ways of doing it, or sometimes easier, or sometimes harder, just all the different ways you could write some of this code. So this is the block that you're referring to, I think, right?
It is, yeah.
So so basically what this is doing, if I could just run it, is it initializes all of the letter counts. So so this gives us a list of numbers 1 through 26. So this gives us a list with 26 numbers in it, really. And then this just is an anonymous function that just returns 0 for everything. So then it makes it so it's a list of 26 zeros. So
I see what it does, and other people probably appreciated the explanation. I was curious about that you can just have a gray ring like that and then put arbitrary blocks in it, ending with a report, I suppose, right?
Yep. Yeah, yeah, yep, exactly. Yeah.
Good.
Yeah.
Thanks.
Yeah, no problem. Awesome. Well, this brings us to time. I'll be adding any extra links to the end of the or to the SnapCon website, there where we have this workshop listed. So I might, so all these links should be copied there. Any ones that are missing, I can always post there as well. And I'll go after there and post some of these new ones that we made. But I hope you enjoyed the workshop. And if there are any other questions, feel free to reach out, you know, through OEA or Zoom or email or whatever method is most convenient.